All right, what's going on, folks? I hope this is working now. Let's see if we can get this Snagit to run well. Um, so check this out. I'm going to do 4 problems for you. I'm going to do as many as I can, or I'm going to show you as many as I can just to kind of expose you more to this math. Hopefully this does 2 things. It's going to set me up to teach you guys real science and how math relates to that science. That's why it's important to me. It will also help you understand your math class better. I'll be honest with you, I'm a big fan of math and science. And you know what? There is a possibility, if you go to this school next year, that I will be your math teacher. So wouldn't it be good for me if I made sure that your math is solid? So I'm going to try to make sure your math is solid so that way when we get into math class, I'm going to make you do this. All right? Also, your math teacher, your current math teacher, is a science teacher. She's a really good chemistry teacher, actually. So, I'm just trying to help a fellow science teacher out too. So, so anyway, we kind of talked about completing the square. I showed you, I gave you the motivation for why you would you take the number and then you divide it by 2 and then you square that whole thing. And the reason for that is because we like seeing perfect squares, right? Like, I spent the whole class kind of motivating for you why you would take a number, divide it by 2, and then square it. So what I'm going to do is I'm going to show you an application. Oh, no. I'll just put number. I put a circle there. It just means you can put anything in there. You divide it by 2 and then square it. That's what I mean. So does that make sense to you? All right, cool. Let me get this chat up and we'll get this thing running. There we go. Facepalm, Vic. All right. So what I'm going to do is I'll make up a problem and hopefully this one works out well and then we'll just keep going from there. Got it? So I'll solve 4 problems for you, and like I said, I'm going to prove the quadratic equation. But for the quadratic equation, I want you to write down what I write down. I want you to look at the proof, but I want you to know that your homework that you will have from me or your math class is going to be a lot easier than what I'm showing you this proof for the quadratic equation. You're not going to be asked to prove the quadratic equation, not even next year when you take Algebra 1 like the high school version, and it's maybe even if it's from me, I won't ask you to prove the quadratic equation just like from scratch. All right? But so why do I even show it to you in the first place? Because my pet peeve, the thing I hate, is when people pull equations out of their butt and throw it up on the board and say, memorize this for the rest of your life, it's going to be useful to you, I promise. My goal is to say, let me show you where this comes from. It's not magic that I pulled out of my hat. It comes from pure logic. You just kind of approach it, and it works. Does that make sense? All right. All right, so I'm going to make up a problem, and hopefully I can make up the right one. It's hard to make up problems on the spot, but let's see. I'm going to have a plus 12, and then I'll have a minus 1x. I think that will work. X squared minus 1x plus 12. Yeah, that will work. Oh, yeah, and it equals 0. Okay? X squared minus 1x plus 12. And I'm going to solve this problem in 2 different methods. First thing I'm going to do is I'm going to complete the square. Got it? And then I'm going to solve it. So, in completing the square, wait, do I want to do 1? No, I'm not going to do 1. Wait. Okay, wait. Erase that problem. I need to come up with a really good problem. X squared. Okay, x squared minus 8x plus 12 And I'll be honest with you, I'm just letting you know, it's hard to come up with problems off the top of your head. Because you have to, like, when I come up with a problem, I have to make sure it's solvable for you guys. So I'm trying to, like, think of the problem and the solution at the same time. Okay, anyway. Let's try this problem. X squared minus 8x plus 12. All right, Sophia is saying, what I want to do is I want to solve for x. And let's take Sophia's approach, okay? So I'm going to subtract 12 from both sides. So I have x squared minus 8x equals negative 12. I agree. I see what you're doing, Sophia. You're trying to get x all by itself. The problem that you're going to have here, Sophia, is this. Usually what we can do is we can factor out an x and we'll have x times blah, blah, blah equals negative 12. And then we take that blah, blah, blah and we divide it. So this becomes blah, blah, blah. And we'll have x equals negative 12 divided by blah, 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 right? But here's the problem. I know you guys get the answer, but hold on, let me go on and finish this. So this is the wrong way. Okay? Because it's impossible. Because the problem is when you pull out an x out of here, you'll have an x minus 8 left over. Do you guys get it? That blah, blah, blah is going to be an x minus 8. And if you divide both sides by x minus 8, you're going to have x equals negative 12 over x minus 8. And that's not solving for x. You didn't successfully get x all by itself on one side of the equation. And you can't. You can't do that. So, no, I wasn't going to tell you to factor. I was just going to say add c plus. Yeah, well, I mean, that's what I'm doing. I'm trying to solve this the old school way. And if this were a linear equation, if this didn't have an x squared on it, then that would be the perfectly correct way to go about it. All right? Now, here's the right way. I'll show you the right way. And this is the correct long way. What we're going to do is we're going to do this trick that I showed you last Tuesday called complete the square. I'll show you how to do it. I want you to take out a piece of paper and write it down. I promise you this lesson will help you. X squared minus 8x plus 12 equals 0. Okay? The reason why I put a big space in between there, and all I did was I rewrote this down. That's all I did. I didn't change anything. But the reason why I did this put that big space is because I wanted to use that trick called complete the square. Do you guys remember what you do? You take this number over here, which is negative 8. You divide it by 2, which is what? Negative 8 divided by 2 is negative 4. Good. And then you square that. So negative 4 squared is negative 4 times negative 4, which is positive 16. Exactly. But I left an even bigger space because you can't just go around adding 16 to things. That's not fair. So you have to subtract 16 at the same time. Because if I add 16 and subtract 16, I didn't change anything. I just kind of like threw that in there because I know that that part will help. Exactly. Adding 16 and subtracting 16 is like adding 0. And I can add 0 as much as I want, and it won't change anything. All right, Sophia, this is what I explained on Tuesday. I thought I was very clear about this. The reason why well, here, let me do this. I'll show you the reason why I added 16 in the first place. Okay? The reason why I added 16 is because I can make this now x minus 4 squared. See these first 3 terms? It's the same as x minus 4 squared. If you don't believe me, let's just do some side work. X minus 4 times x minus 4. First, outer, inner, last, that's x squared minus 4x plus 16. So that's x squared minus 8x plus 16. Look, it's the same thing. Do you see? That's why I added the 16, because it will help me make a perfect square. Now I can write it like that. Do you guys see that? And the reason why I subtracted 16 over here, because I'm answering your question, Sophia, is why did I add 16 and subtract 16 at the same time? Is because I can't just go around adding 16 to one side. I can't just say plus 16 on one side. Why? Because it will help me complete the square. But that's not fair. It's convenient. It's not fair. You need to be fair. Okay, fine. If I'm going to add 16, I'm going to subtract 16 at the same time. Okay, Sophia is saying, well, if you add 16 to one side, why don't you just, instead of subtracting 16, why don't you just add 16 to the other side? Is that what you're saying, Sophia? And my answer is this. I am, essentially. Technically, by adding 16 over here and subtracting 16 to the same side, it would be just like adding 16 to both sides. You see what I mean? If you take this 16 back over, it would become a negative 16. So technically, I did add 16 to both sides. Does that make sense? Okay, all right, so let's move on. So we know that the first three numbers, this stuff I underlined right here, that is the x minus 4 squared. I proved it to you right there. We also know that the negative 16 plus 12, that's just minus 4 equals 0. Are we cool? Okay. So that's my answer. This is called the vertex form of my parabola. It's the same exact thing as that. These are the same thing. They just look a little different. Now, what's the advantage of the vertex form? Now I can finally solve for x. Because watch this. I'll have an x minus 4 squared equals 4. I added 4 to both sides. Yeah. I'm going to take the square root. So I have x minus 4 equals the square root of 4, which is 2. But I have to add in a plus or minus. And I remember you asking me last time, why did you add a plus or minus? What's the deal with that? Right? So I have x minus 4 equals plus or minus 2. Do you guys, do you know why I added? Why I added the plus or minus? I'll show you right after I'm done with this problem. Is that all right? I'll show you exactly why I did it. Okay. Let me just solve for x. So I'm going to add 4 to both sides, and I'll have x equals 4 plus or minus 2. That gives me two answers. That gives me 4 plus 2, which is 6, or 4 minus 2, which is 2. So x equals either 6 or 2. This isn't the quadratic equation. I completed the square. That's all I did. But I didn't do the quadratic equation. No, it's not. All right, I'm going to answer your question. Why the plus or minus? What is the deal with that? Okay, I'll show you. What is the deal with the quadratic, or the plus or minus? To give you two roots? Yes, but why did we put it in the first place? Just to give us that two roots? Let me do this. I think it was Sophia who asked. So I'm going to call it s squared equals 9. And my question is, what is s? If s times itself equals 9, everyone says that s equals 3. And everyone is half correct. I agree with you. 3 times 3 equals 9. Yes, that's true. Sophia is saying s could also equal negative 3. Because negative 3 times negative 3 is positive 9. Exactly. So there's actually two answers to what s is. S is positive 9 or negative 9. So when you're taking the square root of things, you need to add that plus or minus. That's why. Because it accounts for both of those answers, the positive version and the negative version. So when I took the square root of this and the square root of this, I needed to throw in that plus or minus. This plus or minus right here. Because it takes into account the positive 2, because positive 2 times positive 2 is 4, and the negative 2, because negative 2 times negative 2 is also 4. Does that make sense? That's why we're throwing in that random plus or minus thing. You guys get it? All right, I need to do another problem with you. Actually, you know what? I'm going to do one more version of this. I want to show you guys something a little bit different. And here's what this is saying, is what we're actually solving for. And I remember showing this to you. I'm going to go over Desmos, graphing calculator. I was showing you guys about soap bubbles, which is actually really cool, I thought. But this is the math that I'm doing. But let's do this one. X squared minus 8x plus 12. All right, let's graph. Look at this graph right over here. Do you see it? This is the parabola that you get. X squared minus 8x plus 12. All I graphed was the problem that we're doing. Yeah, I have no problem with using Desmos. Okay, but I want you to look at this. Where do you notice the graph crosses the x-axis? At 6, 0 and 2, 0. That's what we solved for. 6 or 2. That's why there's two answers. Because the parabola crosses the x-axis twice. You see what this stuff is doing? Why we do it? Because what we're trying to do is figure out where this thing crosses. Those are called the roots. And how do we find the roots? Well, usually this is equal to f of x equals blah, 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 blah. But in order to find where it crosses 0, you set f of x equal to 0. That's why we have an equals 0. And that's why those roots are 2, 0, because we're setting the y value to be 0. That's what the roots are. That's what it's called. That's why we find it. And if I do this, oh, okay. If I do this, I just put a negative out in front, and it changed the parabola. I know, I understand. You know, I know that it made it a little bit more weird. But see this motion right here? This motion is the exact motion that a basketball would take if you threw it up in the air, or a cannonball would take if you shot it into the air, or a bullet would take if you shot it into the air. It would go into this arc that we call a parabola. Or you know what I always see when I see a parabola? Yeah, well, I mean, a basketball goes up and then it goes down. So, I mean, that's kind of what this parabola is. It's an upside down parabola. But what I always see is, you know where you see a perfect parabola every time? Did you guys ever drink from a water fountain? Or spray a hose in the air? That makes a perfect parabola. That's exactly what it is. And all we're solving for is where the thing lands. It lands here, and it lands there. Because like I said the other day, is when you're playing football, or when you're playing volleyball, or shooting a parabola across the thing, the most important parts to you is where the thing lands, right? That's what you care about. So that's what we're solving for, is where are the roots. Now, I don't have much time. I'm actually going to cut down significantly on the number of problems I'm going to solve. Let me show you guys another thing, one more way to look at this, okay? I'm going to write down the same problem again. X squared minus 8x plus 12 equals 0. There was an easy way to solve this. It's a very easy way. And I didn't show it to you. It's called factoring. I know that you've seen this before. I know that you've done this before. I'm just going to let you know. We use this thing called complete the square. It's a really big tool, and it always works. But factoring, could have worked as well. That's where you make two parentheses, and you have an x over here and an x over here. And then you ask yourself, what are the factors of 12? List them out for me. What numbers multiply out to be 12? 3 and 4. What else? Yes, -3 and -4. 2 and 6. What else? 1 and 12. Can I think of any more? Can you think of any more? I can't think of any more. I think that's it. Right, and then obviously the negative versions of these. Now, which one of these can you mess with in order to get the middle number, which is -8? -2 and -6. So you put a -2 over here and -6 over here, and that's equal to 0. So then you set x minus 2 equals 0 and x minus 6 equals 0. And you'll have x equals 2 and x equals 6. That obviously was the easier way to solve this. Right? Like, I got the same answer. That I could have done. Why did I show you this green way if I could have shown you this blue way? You see what I mean? Why did I do that? No, not because it refreshes your memories. And I'll tell you why. Let's do another problem. I want to show you. And I think it was Victoria who's absolutely correct. X squared plus 8x minus 1 equals 0. Let's do it the easy way. We'll do it the blue way. Ready? Put a parentheses over parentheses. I've got x and I've got an x. All right. What are the factors of -1? What times what will give you -1? There's not a whole lot of options here. 1 times -1. Okay? So instead of having 3 different options, we only have one option this time. Right? 1 and -1. Now, how can I mess with 1 and -1 to give me 8? You can't. Exactly. There is no way that you can mess with -1 to give you 8. I can't add them in any way, shape, or form. I can't subtract them in any way, shape, or form. I mean, if you asked me to give you 0, I'd be fine with that. If you asked me to give you... Actually, 0 is the only one. But I can't give you 8. There's nothing I can do. So, factoring doesn't work here because the numbers aren't nice. You see that? Exactly, Victoria. Factoring is easier, I'll give you that, but it can't always be done. Whereas completing the square is harder and it takes longer. But it always works. The way I describe it is it's like killing a fly with a bazooka or hand grenade. Let's say hand grenade. Okay? Imagine you're playing Halo. Imagine you're playing Halo and you have the missile launcher and the other weapon is a fly swatter. Okay? Obviously, the fly swatter would be a lot cleaner to kill that fly. That's it. You know what I mean? It would be a lot easier, quicker, less cleanup, nicer. Or you could use the missile launcher or bazooka. I don't know what they have in Halo, but you could use one of those really giant guns that 90% of the time end up killing yourself in the process. And you use it. Will it kill the fly? Will the bazooka kill the fly? Yes. And it will always work. Is it hard to use? Yes. Is there a lot of work involved? Yes, but it will do the job. I guarantee that. So that's the way I kind of look at it. Completing the square quadratic equation, a little overkill, but always works. Factoring, it's much nicer. It's much shorter. I agree with you. Doesn't always work. You guys get it? All right. So apparently to solve this problem, we need to use complete the square, CTS, complete the square. So let's do it real quick, and then I have to show you the quadratic equation. I only have 10 minutes to do that, and I ran over last time, and I couldn't do that because I need to get out of here on time. So anyway, let me show this to you real quick. X squared plus 8x minus 1 equals 0. I put that random space in it. We're doing that complete the square thing right now. You take that 8 and what do you do to it? You divide it by 2. So 8 divided by 2 is positive 4. Then you square that and that will give you 16. So I'm going to add 16 again. I'm going to subtract 16 at the same time. Okay? Then what I'm going to do is this first three numbers become x plus 4 squared. Notice how it's a little different from what we had before because I had x minus 4 squared, but then again we had a negative 8. This time we have a positive 8, and so we have x plus 4 squared. Minus 16 minus 1 is minus 17 equals to 0. Does that make sense to you? And then if I want to solve for x, technically I'm done. I put this ending in vertex form. It's now in vertex form. But if I want to solve for x, I want to figure out what it was. Then I'll go like this. X plus 4 squared equals 17. X plus 4 equals plus or minus the square root of 17. Last time we had the square root of 4. The square root of 4 is a nice number. It turns out nice and pretty. The square root of 17, I don't know what that is. I'll have to use a calculator. But I know it's a number. It does exist. I just don't know what it is off the top of my head. I'm guessing it would be like 4.13 or something like that. Because the square root of 16 is exactly 4. So the square root of 17 might be a little bit more than 4. You see my logic there? In fact, if you want, calculate it out. Let's see what we got. Square root 17 equals. Why would I have to do a Capatcha just for, all right, fine. R-E-N-E-R-S for nerds. 4.12. I was close. I actually said 4.13. Anyway, it's 4.12. Sorry, I messed up. All right. So then what I would do is I would say, okay, well then I'm going to subtract 4 from both sides, and I have x equals negative 4 plus or minus 4.12. And that's your answer. Does that make sense? And here's the big tip, is if this ended up being a nice number that we can square, like for example, if this thing ended up being a 16 instead of a 17, because the square root of 16 is easy to figure out, then we could have solved it using factoring. But the fact of the matter is, it isn't a nice number. It wasn't a very nice number for us to use. So we couldn't use factoring. We have to do complete the square. Do you guys feel like you get the steps of complete the square? You understand it? Okay. All right. If you do, let me do this then. I wanted to do one more problem before I did quadratic equation, but I've done a lot of example problems for you. Let me show you the quadratic equation. All right? I'm going to spend the next 18 minutes on that. Hopefully I'll be finished. I'm going to do my best to show you the quadratic equation. Actually, I don't have 18 minutes. I have like 8 minutes, I think. All right. You can go if you want, but I'm going to show the quadratic equation. I want you guys to take out a piece of paper and write it down. I know that you know the quadratic formula, but let me show you where it comes from, not how it works. Anyway, we're going to start off with ax squared plus bx plus c equals 0. I'll tell you what this is. All right, so write this stuff down. This is the problem that we've been solving this whole time. We've just had different numbers for a, b, and c. See, a, b, and c were all different numbers. Actually, that's a, b, and c. But this time, I don't want to solve just numbers. I want letters, because I want to choose any a, b, and c that I want. I want to solve this. I want to do complete the square on this so it always works. All right? Now, step 1. I'm going to pull out an a. So I have a times x squared plus b over a times x plus c over a. And put some space. And that's equal to 0. Why did I pull out the a? I'll tell you why. The reason why I pulled out the a is this. Now, remember, I warned you at the beginning. This is going to be a really crazy looking thing on a piece of paper. Write it down anyway, go through it, and just kind of appreciate the process. All right? Why did I pull out an a? Because I haven't taught you yet how to do complete the square when there's a number in front of the x squared. So right now we're dealing with the stuff inside of the brackets. Kind of remember that a is in the back of your head, but don't really don't worry about it for now. Just we pulled it out. All right? Now I'm going to complete the square. And the way I'm going to do that is I'm going to take this number right here, and what do? I divide it by 2, and then I square it. So what's b over a divided by 2? Well, I just put a 2 down there. That's it. And then I'll square that, so that becomes b squared over 4a squared. Do you see that? Now, don't worry if you don't get it. Just kind of, see, I'm going to try my best to explain everything to you. What I mean by don't worry if you don't get it is I just want you to see this process here, okay? Because it's not magic. I want you to see this process here because to me this is an important part of math. So what I'm going to do is I'm going to add this to my equation. But I also have to subtract this as well. So I'm going to add it and subtract it. So I'm going to have an a x squared plus b over a x plus b squared over 4a squared minus b squared over 4a squared plus c over a. And I have to remember to distribute that a back in there at the end. Does that make sense to you? I'm actually doing the exact same steps as what I was doing before. Remember, you guys were asking me, why did I add 16 and subtract 16 at the same time? That's exactly what I'm doing. I'm just adding this number instead. Okay, these first 3 numbers, that becomes that perfect square. That's the x plus b over 2a squared. I still have that a out in front. You got it? And then these next 2 numbers, I just kind of said, okay, well that is the stuff that's outside. So that would be negative b squared over 4a squared plus c over a. All right, I feel like I feel like it's time for me to multiply in this a. So I'm gonna multiply this a into each term. There's 3 different terms. There's 1, 2, and 3. So I'm gonna bring this a into each of these things. I'm gonna multiply by a. So I have a times x plus b over 2a squared minus b squared over 4a plus c equals 0. The reason why it's not b squared over 4a squared is because one of the a's on top, which is coming from multiplying in that a, got killed. And the reason why it's not c over a is because one of those a's on top killed the a on the bottom. You guys see this step? It's not magic. I'm just... Okay, good. Now what I'm going to do is I'm done, actually. This is in vertex form. But in order to truly finish, what I want to do is solve for x. So let me do that in just a second. Hold on. A times x plus b over 2a squared. So there's no square on the outside of the parentheses, right? Oh, no, there is. That's a square. I'm sorry. All right. What I'm doing right now is I'm going to go b squared over 4a plus c. Or no, not plus c. Minus c. Does that make sense? All right. Who's saying, wait, there should be a b, shouldn't it be a b over 2a? Which one you're talking about? Are you talking about this is a b over 2a or this is a b over 2a? And Jenna, yes, I'm actually really close to that. So if you want to stay for another maybe 2 minutes, I'm going to get to your equation in just a second. Okay? Outside the parentheses, no, it shouldn't be a b over 2a because remember I squared it, so it's a b squared over 4a squared. And then the reason why it changed from a b squared over 4a squared to a b squared over just a 4a is because I multiplied in that a. This a went over here, and I had an a over here and an a over here. And then one of these a's canceled out with one of those, and then this a got canceled out with that one. That's where those a's went. That's why they disappeared. Does that make sense to you? That's what those green arrows mean, is I'm multiplying that in. It's like I'm using the distributive property. Okay, let me finish because I know that I'm already over time and I need to finish now because I can't be late anymore. Anyway, all right, so what I'm going to do is, I don't like fractions. I'm going to combine these 2 fractions. So I'm going to put this divided by 4a and I'm going to have a 4a on top. I can do that because I'm just kind of making the same denominator. We cool with that? So this would be a times x plus b over 2a squared equals b squared minus 4ac all over 4a. And why don't we divide both sides by a, and so I'll have a x plus b over 2a squared equals b squared minus 4ac over 4a squared. You see what I did? All I did is I took this a and moved it downstairs to the other side. I'm almost there. Let me finish off. I'll have the x plus b over 2a equals the square root of b squared minus 4ac all over the square root of 4a squared. Now, notice that I put in that plus or minus, and we talked about why that plus or minus is there is because, when you square root both sides, you have the plus or minus. That bottom part, the denominator of the right-hand side, that square root of 4a squared, that is simply 2a on the bottom. Because the square root of 4 is 2, and the square root of a is or the square root of a squared is a. So I have plus or minus the square root of b squared minus 4ac equals x plus b over 2a. Now, the last part is I'm just going to subtract over that b over 2a. So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since they have the same denominator, 2a and 2a, I'll just combine them. And we're done. This, my friends, is the quadratic equation. And all I did was I completed the square on a very general equation. The general equation was ax squared plus bx plus c equals 0. So if you now ever see a problem that has this form, where a, b, and c are different numbers, then you can just take that answer and plug it into this formula that we have on top. Quadratic formula, and you'll get your answer. And all it is it's completing the square. You're just doing it all in one big step. I'm going to tell you a story real quick, and then I'm going to end this lesson in about 2 minutes. I really want to get it done. All right. There's this boy, okay? He's a boy, and he's negative. He's a sad parabola. He's not a nice guy. He's a negative guy. You guys got it? Negative boy. And he wanted to go to this party, but he was invited to go to this party, but he was really unsure of going to this radical party. So we have boy, unsure. Oh, he was a negative boy. Unsure of going to a radical party. Got it? Negative boy, unsure, radical party. He went to the party, and when he went to the party, he was kind of a square. Boy was square. And I guess what that means in today's lingo is he was a real rigid, like kind of upside, kind of, stuck up kind of guy. And because he was kind of a square, he missed out on talking to 4 awesome chicks. There were 4 awesome chicks at this party. And they weren't chickens. They were like girls. Okay? And he was a square, and so he missed out on talking to them. And this whole party was over at 2 a.m. in the morning. So let me go over it real quick. Negative boy. Unsure. Radical party. Dude was a square. Boy, square. Missed 4 awesome chicks. Over at 2 a.m. You guys got it? Negative boy, plus or minus, unsure, radical party. 4 awesome, or boy was a square. 4 awesome chicks. Missed and divided by 2 a. And, all over at 2 a.m. All right, here's my story. Ready? You got this negative boy. He was unsure. Unsure means plus or minus. Another word for square root is radical. Radical party. Dude was being kind of a square. He missed out on talking to 4 awesome chicks. One of them being Raven, as Raven said. This whole party was over at 2 a.m. in the morning. Now, by the way, Raven, your mom's downstairs. Don't let her know that I called you an awesome chick. You called yourself an awesome chick, and I'm just kind of agreeing with you. Because you're awesome. Anyway, I'm done. Yeah, there's probably 4 awesome chicks over here. Although I don't consider my students chicks, but whatever. Appropriately so. So, this is the quadratic formula. Now you know where it comes from. It wasn't magic. It's just straight up like logic. Have fun with that. I hope this helps. I hope it was fun for you. It was fun for me. All right, talk to you later. Bye.